Welcome, MathLovers. Today we are going to see an interesting problem about greatest integer function and a summation pattern. I'm adding a summation here, starting from 2 power 0 by 3 till 2 power 1000 by 3. But noticingly, like they are all inside the greatest integer function. So whenever we try to do addition on greatest integer function, we need to know what value it creates. The greatest integer function, as the name suggests, is going to give you the integer value recently it has crossed or it being equal to the integer itself. So notice the divisor here is 3, and the beauty is every numerator here is going to give you a reminder of like 2 or 1 only. Because for example here it's 2 power 0, 2 power 0 by 3. So 2 power 0 is 1, 1 divided by 3 remainder being 1. 2 power 1 divided by 3, so remainder will be 2 itself. 2 square divided by 3, remainder will be 4 by 3, remainder will be 1 again. So we understand the pattern here. So I can rewrite this question as, so this will give me a value of 1. So this is going to be 2 power 0 minus 1 by 3. So you can notice the value of this GI function and what I have written here will be matching. Because the number is 2 power 0. The remainder we got was like 1. So I am subtracting 2 power 0 minus 1. That will give me 0 again. 0 by 3 is 0. And here 2 power 1 it is. So 2 power 1 is 2. So 2 divided by 3 remainder is 2. So I am rewriting it as 2 power 1 minus 2 divided by 3. So the 2 square, it's going to be 2 square minus 1 by 3. So you will understand the pattern and it matches to all the reminders. So through this we have successfully removed all the GAF symbols and we have made it just as a simple algebraic expression. So by 3 is a common denominator, and we notice if the power is an even number, then we are having a minus 1. If the power is odd, we are having a minus 2. So I'll take 1 by 3 common out first. And then I'm having all the powers of 2 being added up, starting from 2 power 0, 2 power 1, 2 square till 2 power 1000. So the number of terms available here is, there are literally 1001 terms available. So in that 1001 terms, there are going to be 501 even terms and 500 odd terms. All the even terms is having a minus 1 associated with them. So minus 1 for 500 times will become minus 501. And minus 2 for 500 times will make it minus 2 times of 500. So this is going to be the value of the summation. So any problem made on this style of adding up GI functions, so you need to understand, you need to open the GI function to start doing with the summation. So what we see here is summation of all the powers of 2, which is going to be looking like a geometric progression. The formula for sum of geometric progression is sum of n terms of any geometric progression is given by a times r power n minus 1 by r minus 1, where a is the first term, r is the multiplier. So the first term is 2 power 0 here, which is 1, and r is the multiplier just into 2 every time to get the next terms, and the number of terms is 1001. So 2 power 1001 minus 1 divided by r minus 1, that's going to be again 2 minus 1. So here we have minus 501 and minus 1000, so altogether minus 1501, and outside we have a 1 by 3. So the final answer that we are looking at is 2 power 1001 minus 1 divided by 3 minus 1501 divided by 3. So this will be the final result, people. So any challenging questions that you find in greatest integer function and asking you to add them up, so I wish you should be doing that using the division algorithm. So that's what I have done here. I have rewritten every term here as the dividend minus the remainder with respect to the divisor. Okay, I'll see you again in a very interesting question.